Hello, everyone, and thank you so much for joining us today. I'm your host, Shireen Benzayed, Head of Innovation at Finastra, and we are welcoming you for this live meetup, which is one of a series, part of our Hack to the Future Global FinTech Hackathon. Hack to the Future is a fintech movement igniting a world of financial sustainability, inclusion, and empowerment, and building on the success of our previous hackathons to redefine finance for good and build an unbiased fintech future, we continue to use our position in the market to inspire the fintech space to be open by default for everyone. And this year, we aim to drive engagement beyond our global fintech ecosystem with three key themes that are open and inclusive to all. The first one is sustainable and inclusive finance. The second one is embedded finance and banking as a service. And the third one is decentralized finance. And this week we are on our last week of hackathon. So you've got till Sunday, April 10th to register and submit your idea or project. Also, in case you'd like to learn more or register for the hackathon, you've got the link showing up here. So fintech.devpost.com. And today, in this session, we'll be talking about a very interesting topic. You'll see quite technical one, but with very interesting social implications. And for that, I'd like to welcome Vincent Phan. Vincent, if you can please introduce yourself.
Hello, everyone. My name is Vincent Phan. As Shireen said, I'm a data scientist at Finastra. I actually started working less than a year, but it's been a great time learning all my coworkers. That was actually the inspiration for today's session. We're going to be talking about visualizing multiplex relationships, which I'll tie into the social aspects of ESG.
Yeah, thank you so much, Vincent. So, yeah, I suggest that we get started. For anyone watching us live on LinkedIn or YouTube, please share your questions on the chat and we will take them with Vincent at the end of the session.
All
So,
right.
over to you, Vincent.
So, our agenda today is what is multiplex data? Why is it important? And then a technical demo to show how to use it and visualize it. So, the question is, right, what is multiplex data? It sounds kind of scary, right? But really, it's based on graphs, and graphs are a data structure that can represent relationships between items. They compose of a set of vertices or nodes that are connected by edges, also called links. They may be undirected or directed. As you can see over here, we have an undirected graph. The links between them don't have arrows, which show that you can travel between them both ways. The graph beneath it is a directed graph. So you can see the node for 2 only leads to 5, and it leads to 6, but there are no nodes that lead to 2. Edges may also have a weight, which is an associated cost for using that connection. There are known being shown on the example here, but they would usually be a number on the line itself. It's very useful for path traversal. So some examples of graphs and networks in social media are your graph of Facebook friends, how people are connected to each other. So someone who is a friend with each other on Facebook are going to be connected. The two nodes would be, say, I with my friend Jonathan, we would be connected. We would each be nodes, and then the link together would be our friendship. You can do the same for Instagram followers, Twitter followers, Twitch connections. It's useful in logistics of figuring out road connections, airport connections, train connections, and trucking routes. And it's also used to represent lots of other things like Wikipedia article navigation, text messages, emails, Reddits, similar subreddits are a type of graph, family trees. There's lots of different types of things that you can represent using graph or graphing as a data structure. It just represents anything that's connected to each other, and that's pretty much anything in the world. So some use cases, all right. Well, what's the point of graphs, of visualizing these connections? When you look at it on a graph, it's a lot easier to find groupings of things that are tightly clustered together. You can quickly see points of interest if you scale your nodes based on some specific thing like For road maps, maybe you use population density to make your city nodes larger, and your links will have costs, which may be the miles or maybe even the gas usage, which then we can then use different types of algorithms to find the shortest path between connections. With weights, we can use it to find the fastest or cheapest route between cities. We can determine non-conflicting paths. Some examples are of questions that you may ask that you could use graphs to solve are how do I get from New York City to Miami? And maybe you have to take a specific highway, or if there's a obstacle or traffic on that road, you might want to take another path. If you know Joe, can they refer you to Candace? You can find the connections between those, and it lets you link from one person to another. And you can even use it to solve for specific timings, like using traffic lights. They use graph theory to prevent accidents by making sure like red lights and green lights are never conflicting with each other. So a graph with a single edge connecting two verses is a simplex graph. That's the ones on the left. You can see the road graphs, maybe it goes from A to B. But when you add the word multiplex, it means that there are multiple edges that connect its nodes. You can see that there's a road graph and then there's a rail graph. And if you interplace them on top of each other, you can see that there's the four in the center are connected through road and rail. There are some places that are only connected through roads, but then other places you can, but the middle line you can only take a rail through, but you can also take a road through. We also call these graphs multi-graphs, multi-layer graphs, or multi-dimensional graphs. Multiplex is generally used in the sociology setting, and since we're using these graphs to represent relationships, we have points that have multiple contexts connecting them. So instead of a road and rail, we're thinking of John and Joe, who are maybe coworkers, and they're also friends. So that leads into like, why is this important? What does this have to do with the hackathon and ESG? So multiplex relationships are integral to companies because most people have a simplex relationship in the workplace. They're only coworkers. They wake up, they go to their job, and they only interact with people if they need to for a business relation. Maybe they need documents or they need a specific task done. But according to MIT research, the highest predictor of employee attrition is a toxic work culture. Workers who feel disrespected, workers who feel like there's not a promotion of diversity, equity, and inclusion, if there's a backstabbing and ruthless behavior, it makes it so that it's very hard to go to work and work with people in general and be productive when you don't like interacting with the people there except through a relationship that's forced onto you by the company, which is the fact that you have to work with them. Those who have friends at work are more engaged, produce higher quality work, and have a higher state of well-being. Their moods are just generally better because when you enjoy the people you're around, it affects the way you feel, and the way you feel is how you produce. The benefits of having a multiplex relationship in the workplace is that these social interactions help boost productivity. Co-workers will use their informal friendship networks to discuss projects they're working on. They'll brainstorm on concerns and problems without fear, trade ideas, solutions, and innovations. They'll ask and give advice, and they'll support each other through hard times. These are the types of policies that Finastra really likes to push the feeling of being inclusive, of feeling like when you go to work that it's not work, it's a place that you want to help people to work with each other. And just having friends at work makes a third of the day more enjoyable. You're less likely to burn out. You're willing to talk to people about work because it's more fun to talk to the people you enjoy talking to. Even in disagreements, if everyone is civil and they recognize each other as a human and a friend, it allows the people to be more receptive to criticism and new viewpoints. So we're going to go through a technical demo to show how to visualize these types of multiplex relationships where work or you can see like a person is also a friend and a coworker. The example dataset we'll be using is called the Crackhart High Tech Multiplex Network. It represents the multiplex social network of managers at a high-tech company. It consists of three types of relationships: advice, friendship, and reports to. There are 21 nodes, which means there's 21 people, and 312 connections. The network is directed and unweighted. To the right, we have a picture of what we will create in the technical demo today, but there's 21 nodes on there. They're overlapping with each other, lots of arrows and directional graphs that show the advice and friendship and links between these people. So here's technical demo. So we'll be using NetworkX and Matplotlib today. Those are the only things we really need. And this is from the Cognitive Social Structures paper from the Social Networks Journal. Our file name here. Well, actually, let's take a look first at the actual file we'll be looking at. You can see here it says 1121, 1141, 1181. The first number here is the layer. It tells you that the first layer is the layer of advice, the second layer is friendship, and the third layer is what they report to. So since these are directional nodes, one will point to 2, and then 1 will point to 4, but 2 doesn't point to 1 unless later on we see that it does, which for this first layer, you can see here that 2 does not point to 1, it only points to 6, to 7, and 21. The one on the side is the weight. For this data set, the weight does not have any differences between each other because there is no easy way to measure how much more friendship something is besides through self-reported surveys. But for other data sets, there might be costs related to the connections, maybe if it's related to roads or logistics, or if you're using anything related to genetics or cells, they might have like weights depending on the connections made. But you can see here there are 312 connections and 3 layers. There's 21 people, but even that is a lot when you're pointing them to each other. The libraries we're using, as I mentioned before, are NetworkX. It's a library for visualizing and making easy graphs. Matplotlib is the graph that we will use to plot it out and show everything. So our first line here just gets the name of the file that we're using. It's the edges file, where we open it up, and then we create this multi-dimensional directed graph. So we wouldn't be able to, we could use an undirected graph, but then it would defeat the point of the social connection between things. And we need to use a multi-graph because the edges are linked to each other. We read through each line, and then we add each node and its connection along with its layer. We ignore the weight because for our purposes, we don't need it. And these are some important stats that we'll be using today. These are things that you may want to look at when you're looking at your own graph network. So here is our data visualized and given out with the statistics. So you can see here, it mentions there's 21 nodes, there's 312 edges. These are the specific types of nodes. They're ordered right now in the order they show up in the list. The degrees of the node are the incoming and outgoing connections. So for one, you can see there's 33 degrees, which means that over here there's 21 in degrees and 12 out degrees. This is stacking all the layers on top of each other. The largest in degree node is number 2, which has 31 going in. And then 15 is the one that has the largest going out, 29. It may be advice, friendship, or reports to, which we need to split up later to figure out what we're looking at. Like even this graph here that we're looking at, it's kind of hard to tell what's going on. There's just a lot of points on top of each other. The lines are overlapping, and the nodes are very hard to see. So then I made a function that makes it so that we can make it so that it's easier to see things. First we make the figure size a little bit bigger. We give different colors to the nodes depending on the incoming connections. So the darker it is, the higher its in degree. And then the outgoing node is based on its out degree, or the size of the node is based on its out degree. So I've also added a scale because for some of these it's a little bit bigger and some of them are a little bit smaller. So by adding a scale, we can make the general size of it larger. We use the NetworkX draw NetworkX function to create this graph. I'm using a spring layout, which is a specific type of algorithm to make it so that it compresses the nodes but pushes them out so that it makes it so that it's easier to visualize. Otherwise, you would probably have a random layout, which can sometimes be good and sometimes look really, really hard to see. So let's see what that looks like here. So this is a little bit easier to see now. Now you can see that 2 is very dark, so it has a large amount of in degrees. And then you can see that 15 is very large, so that means that it has a large amount of outgoing degrees. This is still a fully stacked graph, so we have all the advice, friendships, and reports too, which still makes it very hard to tell what's going on. We just see that lots of things are connected to each other. We can see that 15 and 21 are like kind of in the center and they're very congregated, but it's still very hard to tell. 13 you can see is like pretty much white, which means that there's like no amount of out degrees. It's mostly receiving things. But now we split up each parts of the layers so that we can see each graph individually. So now we can see a graph that shows us only based on advice. We can see that 21 receives a lot of advice, 2 receives a lot of advice. It's very dark purple, whereas 13 and 12 do not receive that many advice. But then you can see the larger ones, 15 gives a lot of advice. 15 you can see here is the highest out degree. It gives out, it's connected to 20 other people. So this person, 15, number 15, likes to talk to other people. He gives out lots of advice. He doesn't really receive that much advice, but we can but maybe that's something to like identify and talk to. So you can use these types of graphs to then work with policymakers and people in your company to identify these individuals to find out what they're doing differently. Is 15 just a naturally extroverted person that likes to give advice? Is he in a high position that wants to, or that he mentors a lot of people? We want everyone to be like very large. We want everyone to be dark, so that that means that everyone is receiving and giving out advice equally. You can see over here, number 6 is really small. So that means that they don't really give out advice. They mostly receive it. But even then, it's pretty purple. So that's someone that we might want to identify and talk to. And maybe we can see the friendships. You can see here it's like much more tightly clustered. That shows that there's lots of people who are well connected to each other. 17 is pretty large. He goes out and makes he becomes the friends of lots of people. Whereas 2 is someone who receives lots of friendships. And then on this graph, maybe we want to identify people like 7 and 9 who don't really seem to be interacting with lots of people. Those are maybe people who are at risk of attrition, of feeling like they're left out, of feeling not like, of they're not included and or they're not feeling like this is a culture that they want to belong to. This hierarchy shows that there's people who report to 14 a lot. There's people who don't report to anyone. And then there's like people who everyone reports to. You can then use these types of graphs to stack them on top of each other and look. We can then use the idea of these things as 14 or 2 over here has 2 direct reports, 1 and 16, but he then reports to 7. So he's not really a manager, or he is a manager, but he's not a big director like 14, which may be a type of manager that we want to encourage to show leadership because he is a person who likes to give and receive advice. 15 is someone who seems like they're very good at giving advice, which means that maybe we should talk to this person and see that they are not someone who is the report or is the reporting manager of. So 15 maybe what should be considered for a promotion. These graphs we can use to visualize data and see different ways that we can visualize and help the company. So these are the types of graphs we created, and now we did some analysis on them, and these are the areas that I got ideas from. The data source I got from Manlio de Domenico. He's a research scientist. This is the specific data set I got it from. These are some blogs that are related to our idea of social interactions and multiplex relationships. And this is the libraries I used. If you guys have any questions, then just write them in the YouTube comments or in the chat box, and Shireen will direct them to me. But that was my presentation. Thank you for your time.
Thanks a lot, Vincent. Thank you. Thank you so much for the presentation here. We've got actually a couple of questions. So first one from James asking actually, how do you quantify or define the nature of a relationship in the workspace versus so whether it is friendly relationship versus a work-only relationship?
Mhm. So that's the hard part. That would be the weight of the edges, and we can't really quantify that. We can't really say like this person is 10 times more of a friend than or from A to B versus from B to A. We can only really do these self-surveys based on what people consider themselves to be friends. Of course, reports too is a quantifiable metric that is something that they do or that is factual. Friendships are, but that's why we have the directional graphs of the friendship graphs. It's while B may consider themselves a friend to A does not consider themselves a friend to B, and you have a directed graph that only goes one way. So B considers himself a friend, but A does not. And that may lead to the other graphs of advice giving. Like B might give advice to A thinking that they're friends, whereas A does not like receiving them, nor do they give advice back.
Cool, thank you. The other question actually I had for you, Vincent, is how do you see this possibly be used by the hackathon participants? Or do you see any fintech application of the framework that you've presented today?
So we don't have to, just because they're multiplex relationships and this connects to the ESG theme of social, you don't have to only use it in the social aspect. Multiplex relationships are very important to lots of different types of uh, messages, as we saw before. For examples, emails and text messages are a type of graph. You can just see those like the receiving and connections, and you can do the same thing for financial transactions. Maybe we're looking for bias or fairness in our financial transactions, and you can see that one person receives much more than other people, an outlier perhaps of receiving, whereas like when it comes to financial transactions, everyone should be equal. You can see the same thing with hiring rates. If someone is hiring things, maybe you can add a specific graph related to diversity or inclusion, and you can notice that one team may perhaps only have much more of a specific type of person than others. You can see that we can use we can use graph reversals and theories to work for DeFi and see types of wallets. The point of decentralized finance is to remove fees and make transactions instant. But if you're seeing someone that is a large node and has lots of edges and pass-throughs, they may become a middleman, which kind of defeats the point of decentralized finance.
Yeah, definitely interesting. So, lots of ideas here for the hackers maybe to explore further. I don't think we have any more questions, Vincent. So
All right.
Yeah, I'd like to thank you very much for this very insightful session. I really enjoyed it, learned a lot, and I think this is just the start of the conversation. So for anyone interested in pursuing the conversation here and learning more about the topic, please feel free to connect with Vincent or myself. Also, just a quick reminder that we will be still running the hackathon, Hack to the Future, for till the 10th of April. So 4 or 5 days left for you to take part. Make sure you visit fintech.devpost.com, register, and have your submissions added by end of this week. Thank you so much, Vincent, again.
Yep,
Thank
no
you,
problem.
everyone.
Yep, thank you for your time,
And
everyone.
thanks a lot. Bye bye.
Bye.